Hello and welcome to Astronomy Daily, your daily dose of space news from across the cosmos. I'm Anna.
And I'm Avery. It's Friday, the 19th of June, 2026, and we have an absolutely packed show for you today.
We're talking salty skies on a mysterious pink world, black holes with serious indigestion, a new batch of spy satellites heading to orbit right now, and a lunar lander that could be the cornerstone of humanity's first moon base.
Plus, we'll find out what a NASA spacecraft learned from a double-lobed asteroid that's been slowly reshaping itself for more than 100 million years. And we'll celebrate a little robot that's just run a marathon on Mars.
If you're watching on YouTube, smash that subscribe button. If you're listening wherever podcasts live, a review means the world to us. Let's get into the news.
Our first story today is a gorgeous piece of science from the James Webb Space Telescope, and it involves a world that astronomers have been desperate to study for over a decade.
JJ504b, the Pink Planet. It was first discovered back in 2013, and it got that nickname because of its distinctive rosy, hazy appearance. It orbits a sun-like star about 57 light-years from Earth.
And here's what made it so tantalizing and so frustrating at the same time. It's one of the coldest planetary mass companions ever directly imaged, sitting at around 550 degrees Fahrenheit. For context, that's roughly the temperature of a domestic bread oven.
Which sounds hot to us, but for directly imaged worlds, that's genuinely frigid. Most are between 1,000 and 2,000 degrees Fahrenheit. The Pink Planet was so cold and so faint that every attempt to study it from the ground failed. Teams around the world tried and came up empty.
Which made it a perfect target for Webb, and a team led by Anish Baburaj at Northwestern University Center for Interdisciplinary Exploration and Research in Astrophysics, Sierra, finally cracked it open.
The results were published yesterday in the Astronomical Journal, and they are wild. The atmosphere of GJ504b is filled with exotic chemistry, heavy elements including carbon, oxygen, nitrogen, and sulfur. But the real headline finding?
Salt clouds. For the first time ever, astronomers have found direct evidence for salt clouds in a cold object's atmosphere. Scientists had theorized this was possible more than 15 years ago, but nobody had actually seen it until now.
Baburaj and his team ran simulations testing 3 different types of clouds, and only the salt cloud model produced results that were physically consistent with the Webb data. When they accounted for the salt clouds, previously confusing molecular signatures in the spectrum suddenly made sense.
There's also a twist about what this object actually is. With a mass of around 25 times that of Jupiter, the Pink Planet might not technically be a planet after all. It may be a brown dwarf, a so-called failed star, something that formed like a star but never accumulated quite enough mass to ignite hydrogen fusion in its core.
The team also found that GJ504b appears unusually rich in metals, elements heavier than hydrogen and helium, and is likely between 2.5 and 4 billion years old, which explains why it's cooled down so much.
There are still open questions. Exactly what kinds of salts make up those clouds? Is it truly a planet or a brown dwarf? Both questions may require further Webb time to answer, but what a first look.
Baburaj put it beautifully. When we finally obtained its spectrum, it immediately looked interesting. But once we started digging deeper into the data, we realized it was not like anything we had analyzed before.
The Pink Planet. Salty, ancient, mysterious, and finally starting to give up its secrets.
Story 2, and we're staying in the world of exotic astrophysics, this time with supermassive black holes, and specifically with what happens long after they've devoured an unfortunate star.
So, to set the scene, every so often a star wanders too close to a supermassive black hole. The black hole's gravity shreds the star apart in a process called a tidal disruption event, or TDE, producing a brilliant flash of optical, ultraviolet, and X-ray light from the center of what was previously a quiet galaxy.
This initial flare fades over weeks to months, and historically, that's when astronomers stopped watching. The show seemed to be over.
But it turns out the show was only just getting started. Using the NSF's Very Large Array Radio Observatory in New Mexico, one of the most sensitive radio observatories on the planet, a team led by Kate Alexander at the University of Arizona has discovered that a surprising number of these TDEs produce a powerful delayed radio burst, months or even years later.
Like a cosmic belch?
Exactly, like a cosmic belch. Alexander herself said at a press conference this week, sometimes after it seems like they are done eating, they may get indigestion and let out a large radio burp. These late-time radio burps can appear when the black hole eats too fast or eats too slowly.
Which I love because it turns out the universe has the same dietary advice as your GP.
The team assembled the largest sample of TDEs ever studied at radio wavelengths, and they found that roughly 40% of all TDEs eventually produce this delayed radio emission. That is a much higher rate than anyone expected.
And crucially, they've worked out how to predict which ones will burp. TDEs that later produce delayed radio emission are less likely to show helium emission lines in their early optical spectra. That early chemical fingerprint is a signal to keep watching.
This has real practical implications for telescope scheduling. Radio follow-up of TDEs was typically abandoned if nothing showed up in the first year. This research shows that's far too soon. These events are long, evolving stories, and the most energetic chapter may unfold years down the track.
What we're seeing here is a window into how supermassive black holes grow, launch outflows, and reshape the galaxies around them. And the VLA is giving us a front row seat.
Worth noting for our dedicated listeners, this is distinct from the Jetty McJetface story we've discussed before. This new VLA research covers a whole population of TDEs and establishes the general rules, a really significant step forward. Story 3, and this one is happening as you listen, literally right now.
SpaceX launched NROL-179 from Vandenberg Space Force Base in California in the early hours of this morning, Friday, the 19th of June. That's mission number 14 in the National Reconnaissance Office's rapidly expanding Proliferated Architecture program.
And for those not across this program, it's worth stepping back to appreciate the scale of what the NRO and SpaceX are doing together. The proliferated architecture is a new approach to reconnaissance from space. Rather than a small number of large, expensive satellites, the NRO is deploying a constellation of many smaller satellites that are faster to build, cheaper to replace, and far more resilient.
To stay ahead of the competition and ensure it can continue to operate in a heightened threat environment, that's the official framing from the NRO, the agency is modernizing its architecture in space and on the ground, delivering more capability faster with increased resilience.
NRO L179 is the 71st Falcon 9 launch of 2026. 71 launches, and the year isn't half over. That is a pace that was simply inconceivable a decade ago.
Of the 70 launches so far this year, 57 have been devoted to SpaceX's Starlink broadband constellation, demonstrating just how much of the company's cadence is now driven by its own satellite business.
SpaceX live-streamed the launch up until shortly after liftoff, but then ended coverage at the NRO's request. The number of satellites deployed and the details of their orbits remain classified. Standard operating procedure for this program.
What we do know is that this network has now grown to become, in the NRO's own words, the largest and most capable government constellation in orbit in U.S. history. A remarkable statement. Story 4, and we're heading to the moon, or at least to the Pittsburgh company that's building the spacecraft that's going to the moon.
On Monday, June 15, Astrobotic held a public unveiling of its Griffin 1 lunar lander at its headquarters in Pittsburgh, Pennsylvania. And this isn't just another moon mission. NASA has formally designated Griffin 1 as Moon Base 2, the second mission in its planned program to establish a permanent human presence on the lunar surface.
Griffin 1 is what Astrobotic CEO John Thornton called the first infrastructure-class lander going to the surface of the moon. That's a meaningful distinction. Previous commercial landers, including Astrobotic's own Peregrine, which launched in January 2024 but suffered a propulsion failure and couldn't attempt a landing, were relatively small payload delivery vehicles.
Griffin 1 is in a different class. It has a payload capacity of 660 kilograms. It will carry 10 payloads from 6 nations to the lunar South Pole region, specifically the Noble Crater area near Mons Mouton.
The headline payload is Astrolab's FLIP rover, the Flex Lunar Innovation Platform. At 500 kilograms, it will be the heaviest commercial payload ever delivered to the lunar surface. It's carrying 4 NASA science instruments and will help demonstrate the mobility systems that future lunar terrain vehicles will need.
Other payloads come from ESA, Canada, Germany, Japan, and Australia, which is always nice to call out for our audience here in the Southern Hemisphere.
The lander is currently completing final integration at Astrobotic's Pittsburgh facility before being shipped to NASA's Jet Propulsion Laboratory in California for environmental testing. After that, it heads to Cape Canaveral for launch preparations, with the FLIP rover joining it there.
Launch is targeted for the fourth quarter of 2026 with a SpaceX Falcon Heavy, so we may be watching this one land before the year's out.
This mission comes in the wake of Voyager Technologies' acquisition of Astrobotic in a deal valued at up to $300 million. So the company arrives at this milestone moment with new resources and a new parent. Thornton summed it up well. This lander will be part of the cornerstone of building the moon base on the surface of the moon.
From a company that started nearly 2 decades ago and has had its share of heartbreak, here's hoping Griffin sticks the landing.
Story 5, and this is one of my favorites today. An asteroid with an extraordinarily rich life story, now told in remarkable detail thanks to NASA's Lucy spacecraft.
Lucy is on its way to study the Trojan asteroids, the ancient rocky bodies that share Jupiter's orbit and are considered time capsules from the early solar system. But on April 20th last year, it made a practice flyby of a small main belt asteroid called 52246 Donaldjohanson.
Named after the paleoanthropologist who discovered Lucy, the famous hominin fossil, which is a lovely bit of naming symmetry.
The flyby was brief, just a close pass at 960 kilometers, but it was extraordinarily productive, and the results, published yesterday in the journal Science, reconstructed a 155 million year biography of this little world.
The first thing you notice from the Lucy images is Donaldjohanson is a contact binary, 2 distinct lobes of rock fused together at a narrow neck. Like a cosmic snowman, if snowmen were made of ancient asteroid rubble.
The team, led by Simone Markey at the Southwest Research Institute, mapped craters across both lobes and found them saturated, so old that new craters are simply obliterating older ones. Based on impact statistics for the main asteroid belt, the surface is at least 40 million years old.
That's consistent with Donaldjohanson being a member of the Origone asteroid family, a collection of fragments from a parent body that was catastrophically destroyed around 155 million years ago. The 2 lobes are likely pieces of that original smash-up that eventually found each other and merged.
But here's where it gets genuinely fascinating. The neck connecting the 2 lobes is younger than the lobes themselves, smoother, with far fewer craters, estimated as less than 20 million years old. So how do you get an old body with a young neck?
The answer lies in the asteroid's rotation. Lucy confirmed that Donaldjohanson rotates extraordinarily slowly, once every 252.6 hours. That's more than 10 Earth days per rotation. And it's tumbling as well, with a second wobbling period of 455 hours.
This ultra-slow spin is the key to everything. When contact binaries first form, they're typically spinning fast. Centrifugal force counteracts gravity and pushes material outward towards the ends. But over millions of years, pressure from sunlight, a subtle but relentless force called the Yorp effect, gradually slows the rotation.
Once the spin rate drops below a critical threshold, somewhere around once every 10 hours for Donaldjohanson, gravity takes over from centrifugal force, and suddenly loose material on the smaller lobe starts sliding toward the larger one, like sand flowing down a hill.
Every new impact rattles the asteroid. More landslides, more regolith flowing towards the center. The neck gets built up over time, layer by layer, smoothed by millions of slow-motion avalanches. That's why it's younger than the rest of the body.
What I love about this story is that it shows what a brief flyby can actually reveal when you have the right instruments and the right analysis. The Lucy team measured this asteroid for a matter of hours and pieced together a geological narrative spanning over 100 million years.
And this was the practice run. In August 2027, Lucy will fly past Burps, a Trojan asteroid more than 10 times the size of Donaldjohanson. If we learned this much from a quick pass at a small main belt rock, the Trojan encounters are going to be extraordinary.
The solar system's history, one flyby at a time.
And our final story today is one that deserves a moment of genuine celebration.
NASA's Perseverance rover has now driven more than 26.2 miles across the surface of Mars. In other words, it has completed a marathon on another planet.
Percy, as the team affectionately calls it, landed in Jezero Crater on the 18th of February 2021. It has been trundling across the Martian landscape ever since, drilling rocks, collecting samples, taking panoramic images, and doing science that would have seemed like science fiction not long ago.
26.2 miles, or 42.2 kilometers, in just over 5 years. That sounds slow, and compared to a human marathon runner, it obviously is. But remember that for Percy, driving is the interruption between science. The rover's days are filled with drilling, abrading rock surfaces, calibrating instruments, and studying ancient geology.
And the terrain it's traversing now, beyond the western rim of Jezero Crater, is some of the most scientifically valuable ground of the entire mission. Ancient fractured rocks, igneous minerals that predate the formation of Jezero itself, geological structures that may preserve evidence of Mars's earliest history.
Perseverance is also approaching the distance record for any rover on another planet. The record currently belongs to NASA's Opportunity rover, which managed 45.16 kilometers over roughly 14 years before a global dust storm ended its mission in 2018. Percy is closing in on that record, with the mission planned to continue through at least 2028.
To put that in perspective, if you were standing on the Martian surface watching Perseverance go by, you'd be experiencing temperatures that could drop to minus 80 degrees Celsius overnight, breathing nothing at all, and being bombarded by radiation. The fact that this rover not only survives but thrives in that environment and keeps doing world-class science is a genuine engineering marvel.
Mars, one soul at a time. Congratulations to the entire Perseverance team on this milestone.
And that wraps up today's edition of Astronomy Daily, your Friday fix of the best space and astronomy news from across the cosmos.
A beautiful lineup today. Salty alien skies, belching black holes, a landmark moonlander, the remarkable story of an asteroid that's been renovating itself for millions of years, and a little rover hitting a major milestone on the red planet.
If you enjoyed today's show, please take 30 seconds to leave us a review wherever you listen. It makes a genuine difference in helping new listeners find us.
You can follow us on social media at Astro Daily Pod. Visit our website at astronomydaily.io for show notes and transcripts. And if you're watching on YouTube, subscribe and hit the bell so you never miss an episode.
From all of us here at Astronomy Daily and the Bytes.com podcast network, have a wonderful weekend. Keep looking up, and we'll see you back here on tomorrow with our weekend wrap.
Clear skies, everyone.